Good day, everyone, and welcome to our discussion, The Nano World, under Chapter 3, Specific Issues in Science and Technology. Now, our lesson objectives. At the end of this chapter, the student should be able to: first, define nanotechnology and nanomaterials. Second, categorize various nanomaterials used in different fields. Third, evaluate the impact of nanotechnology in varied aspects of human life. And lastly, examine the application of nanotechnology. But before we start our discussion, allow me to present to you a short video clip for you to have a brief introduction to our topic. Sit back, listen, and enjoy learning.
The world is shrinking. There's a deep and relatively unexplored world beyond what the human eye can see. The microscopic world is truly alien and truly fascinating. I'm delving further than the microscopic scale. I'm going to explore the potentials of working at a nanoscopic level, working at a level a billion times smaller than the average scale we work at today. This is nanotechnology. Nanotechnology means any technology on a nanoscale that has applications in the real world. Nanotechnology is the science of building small, and I mean really, really small. It's pretty difficult to imagine how small a nanometer is, but let's just take a moment to try and wrap our heads around it. The tip of a pen is around 1,000,000 nanometers wide, so nowhere near close. A single sheet of paper is around 75,000 nanometers thick. A human hair is around 50,000 nanometers thick. And I ran out of things to compare. Let's just take a different approach. If a nanometer was the size of a football, the coronavirus would be the size of an adult male. A donut would be the size of New Zealand, and a chicken would be the size of the Earth. In fact, on a comparative scale, if each person on Earth was the size of a nanometer, every single person on the planet would fit into a single car. A Hot Wheels car. You get the idea. Nano is super tiny. We're talking subatomic. So that's how big, or rather small, a nanometer is. But why does it matter? Why look at really small things? Well, they ultimately teach us about the universe that we live in, and we can do really interesting things with them. When we move into the nanoscale, we can work with new domains in physics that don't really apply at any other scale. Nanoscience and nanotechnology can be used to reshape the world around us. Literally. Everything on Earth is made up of atoms. The food we eat, the clothes we wear, the buildings and houses we live in, our own bodies. Now, think for a moment about how a car works. It's not only about having all the right parts, they also need to be in the right place in order for the car to work properly. This seems obvious, right? Well, in pretty much the same way, how the different atoms in something are arranged determines what pretty much anything around you does. With nanotechnology, it's possible to manipulate and take advantage of this.
I hope you learned something in the video presented. So, do you imagine how small and thin nano is? Let's find out. Nano. The term nano means the billionth of a meter or 10 meter. To illustrate the size of nano object, for example, a sheet of paper measures around 100,000 nanometers in thickness, and a typical hair strand measures between 50,000 and 180,000 nanometers in diameter. See? Do you imagine gaano ka-thin, gaano ka-small ang nanometers? Na ito mismong papers na to is around 100,000 in nanometers. So, gaano ka-thin ang 1 nanometers na can see ng naked eye natin, na hindi makita-kita ng naked eye natin, only using microscopes. According nga doon, for example, doon sa videos, ang example nila doon, if the size of nanometer is like a football, so the coronavirus is like a human or adult male. A donut is like a New Zealand, and a chicken is like the size of a Earth. And then, if a human is the size of nanometer, if yung tao ay size niya is nanometer, then the people or ang tao is like the size of a car in the world. See? Gaano ka-thin, gaano ka-small, gaano kaliit ang nano. So let's now move on to nanotechnology and nanoscience. Nanotechnology, it is emerging technology. It is technology with the dimensions of less than 100 nanometers. It is also referred to as atomically precise technology or APT. Nanotechnology, it is like working with really tiny building blocks or atoms or molecules. Nanotechnology is to create or to build new devices or new materials with special properties. So, meaning to say, ang ibig sabihin nun is nanotechnology. It is the technology na ginagamit ng scientist para bumuo, mag-imbento ng mga bagong devices and materials na makakatulong sa atin and then sa different field of science. So, let's now move on to nanoscience. It is the studies, the phenomena, properties, and responses of materials at the atomic, molecular, and macromolecular scales. Ibig sabihin, nanoscience, it is the study and the research of the things that are extremely small things or small scales. Scientists examine the unique properties and behaviors of material when they are very small. So, ibig sabihin, the goal of nanoscience is to understand, maintindihan natin, and to improve the application and technologies na kakailanganin natin as a human na beneficial sa atin and then sa environment. Nanoscience and nanotechnology employs the study and application of exceptional small things in other areas of science, including material science, engineering, physics, biology, and chemistry. Kagaya nga ng sabi ko kanina, nanoscience and nanotechnology ay nakakatulong sa atin sa different field of science, mapa material science, engineering, physics, biology, and chemistry, according yan sa NNI 2017. And then always remember na ang nanoscience and nanotechnology, it is the science of a small things. Additionally, nanotechnology and nanoscience are relatively new innovations. However, the use of nanomaterials dates back to us as early as the 4th century AD. Meaning to say, the use of nanomaterials has been discovered or observed since ancient times. Ibig sabihin, dati na nilang na-discover, ino-observe yung nanomaterials. However, nowadays kasi, mas advanced na tayo. Mas advanced na yung mga ginagamit nating microscopes para makapagbuo or para makadiscover ng new devices and new materials. Moreover, these are the facts, some facts in nanoscience and nanotechnology. First, a nanometer is a billionth of a meter or 10 to the power of negative 9 of a meter. That 10 to the power of negative 9 is a billionth of a meter. Next, an inch has 25,400,000 nanometers. The thickness of a paper is around 100,000. A strand of a human DNA has a diameter of 2.5 nanometers. A human hair has around 80,000 to 100 nanometers. And lastly, 1 nanometer is the length a human fingernail grows in a second. Based dito sa picture illustrated, DNA times 1,000 is the size of bacteria. And then the size of bacteria times 1,000, size of a large raindrop. Imagine nyo gaano kaliit ang nano. 'Di ba? Sa tingin nyo, itong hawak kong tissue, ilan kaya gaano kaya karami ang nanometers dito? Sa tingin nyo, itong buhok ko, kung ang one strand is equivalent to 80,000 to 100 nanometers, ilan kaya lahat, ilang nanometers ang buong hair ko? Ang makahula may ice cream. Charot. 'Di ba? Na-imagine nyo na hindi makita-kita ng mata natin kung gaano kaliit ang nano. Next, the concept of nanotechnology was introduced by Richard Feynman in December 29, 1959 in his lecture entitled There's Plenty of Room at the Bottom at Caltech. The term nanotechnology was first used by Nario Taniguchi in 1974 to describe the processes of separation, consolidation, and deformation of one atom of one molecule. Next, in the 1980s, two important microscopes were invented to further study nanomaterials, the scanning tunneling microscope in 1981 and atomic force microscopes in 1986. First microscope is scanning tunneling microscope, a high-resolution microscope using neither light nor an electron beam, but with an ultrafine tip able to reveal atomic and molecular details of surfaces. STM was invented in 1981 by two IBM scientists named Gerd Binig and Heinrich Rohrer. Take note of the two scientists who invented scanning tunneling microscope. Ibig sabihin that STM is a powerful microscope that can be see both atomic and molecular details of surfaces without using light or electron beam. This is the example. The illustrated picture is the example of scanning tunneling microscope. The second microscope is atomic force microscope. AFM is typically used to obtain three-dimensional surface image or to determine the surface roughness and thin films and crystal grains. Atomic force microscopy or AFM is a high-resolution non-optical imaging technique first demonstrated by Binig, Quaite, and Gerber in 1985. Meaning, atomic force microscope is a powerful tool used to create detailed 3D or three-dimensional image surfaces at atomic level. Ito yung example ng atomic force microscope. So, what are the two microscope? First, the STM, and then second is the AFM. Now, the question is, what are the applications of nanotechnology? The first application is nanotechnology in medicine, a field of medical science made possible through nanobots or nanorobots and nano-engineered devices. The application of nanotechnology in medicine is known nanomedicine. This involves the application of nanomaterials in medical technologies which are efficient in providing greater understanding of issues on toxicity and impact of nanomaterials on environment. What is good about nanoscale technologies is that they can be implanted in the body because they are less invasive and very small. Meaning to say, nanotechnology, it is nanomedicine. It is the application of nanotechnology in the field of medical science. Nowadays, it is very easy to manipulate or to use nanobots. For example, scientists and doctors use nanobots in chemotherapy, in cancers, or they use nanobots in discovering your body. It is very easy to monitor your body or to discover your cells, chromosomes, and other part of your body. The second application is nanobiotechnology. Nanobiotechnology is also known as nanobiology. It is described assisting medicine and producing cures and help in regenerating biology tissues. An example is the growing of organs outside the body and later implanted to those who need it. While it is a new development, this process is considered very useful in the future once it is perfected. Although biological systems are fundamentally nano in scale, nanoscience must work hand in hand with biology and to deliver processes very close in nature. Meaning, biotechnology is the application of nanotechnology in biology. It improved medicine, provide cures, and help in regenerating tissues. Like yung example nila dito is growing of organs outside the body. Minomonitor nila yun, pinapangalagaan nila yung body parts before i-implant sa other person. And another example, it can be directly put good drugs in the tissues or cells of other person. Gets po ba? Nanobiotechnology. Next, agriculture. Nanotechnology application to agriculture industry may impact society and economy. Engineered nanoparticles serve as nanocarriers which may contain genes, herbicides, or nanocapsules containing herbicides effectively penetrate through release of fertilizers, help save fertilizer consumption. This process can help minimize environmental pollution, which is very efficient in precision farming. These developments in nanotechnology applied in agriculture provide promising opportunities. In the field of agriculture naman, gumagamit sila ng mga nanoparticles na merong genes, herbicides na nakakatulong for fertilizer, and then para makatulong sa na maiwasan ang environmental pollutions para mas healthy yung plants, mas healthy yung land. That is nanotechnology in agriculture. Next, green nanotechnology. This is why green nanotechnology is considered as the development of clean technologies in order to mitigate the impact of nanotechnology products not only to the environment but also to human health. This is done through utilization of alternative energy system, green chemistry, and green engineering to develop nanomaterials and products with no toxic ingredients. Excuse me. With less energy and renewable materials. Green nanotechnology ensures that negative effects are anticipated during the full life cycle of products. In green nanotechnology, tinatawag nila to clean technologies kasi it is the technologies na gumagawa para mapangalagaan yung environment natin. Gumagawa sila ng alternative way ng, for example dito, yung energy system, green chemistry, and green engineering. Pinoprotektahan nila yung mga natural resources natin and then gumagawa sila ng mga clean technologies para mas mapahaba or para mas mapaayos yung environment natin. Para mapanatili yung clean and green environment natin. Next, nanoelectronics. Nanoelectronics refers to the use of nanotechnology and electronic components. This is referred to the variety of devices and materials on nanoscale. Atomic interactions and quantum mechanical properties make the workings on these devices possible. Its dimension range between 1 nanometer to 100 nanometer. Beneficial as it is, nanoelectronics can reduce power consumption on electronic devices and allow the increase of capacities of memory chips. Further advancement in nanoelectronics can accelerate the process of fabricating revolutionary devices and materials. For example, ng nanoelectronics, yung mga chips, mga small chips, memory chips baga, na makikita natin sa computers, yung mga kadalasan, hindi mo talaga maano yung mga, makikita mo yung mga silver part, yung mga sa electronics chips baga. Yon. That is nanoelectronics. Lastly, nanotechnology in warfare. The application of nanotechnology in the field of warfare made greater advancement in weaponization. Nanoweapons through nanotechnology are used to produce hyperreactive explosives and small robotic machines. Defensive military apparatus were developed to become lightweight and durable while enhancing offensive strategy. Nanotechnology as it is being utilized for the advancement of warfare comes with greater threat to international peace. These developments raise issues and discussions related to the impact of such development on geopolitics, the environment, and ethics.
Nanotechnology in warfare refers to the use of very small materials and devices to develop advanced weapons and defense system. In this, nanotechnology in warfare, ito yung mga ginagamit ng mga military ng army na advanced weapons and defense materials. Like, for example, yung mga improving armor, body armor, yung mga equipment, yung mga effective weapons like barrel and bomba. And then, another example, yung mga nanosensors that can be used for detecting or merong mga chemical and other agents like drugs na mismo pag ginamit ng mga army is directly siya sa specific targets. Merong magkukos siya ng malaking damage. As in, pag boom, as in, wasak ka talaga. Pwedeng wasak ka talaga or pwede ring minimizing collateral damage lang doon sa specific targets mo. Tapos, yung paggamit nito, pwedeng yung iba gumagamit ng bomba or explosive na mismo powerful talaga pag ginamit mo. And then yung iba gumagamit lang ng mga nano weapons like barrel na merong nanomaterials.
Let's now move on to two approaches in nanotechnology. The top-down approach and the bottom-up approach. The top-down approach One application of this approach is device miniaturization in the electronics industry from micro and nano electronics. While the bottom-up approach is when the materials creates itself. The approach includes self-organization or self-assembly of living systems.
These are the examples of two approaches in nanotechnology. The picture tells us that top-down approach means starting with a large piece of material and cutting it down to create tiny structures or particles. Ibig sabihin, it's like carving a big block of food ngaya, for example, into a smaller pieces to make something. And then, ang bottom-up approach naman is the opposite of top-down approach. Means, it's like starting with individual atoms or molecules and building them up to create larger structures or particles. Ibig sabihin, top-down approach is starting big and making it smaller, while bottom-up naman is starting small and building it bigger. Additionally, solid particles in a visual scale have properties that are different from nanoparticles. Particles at the nanoscale have unique physical, mechanical, chemical, and optical properties. Nanomaterials and nanoparticles such as carbon nanotubes, floor nest, quantum dots, quantum wires, nanofibers, and nanocomposites are already being utilized for various commercial products.
Furthermore, we have four types of nanomaterials. First, carbon-based materials.
Carbon-based materials are mostly made up of carbon in the form of hollow spheres, ellipsoids, or tubes. The hollow spheres and ellipsoids are referred to as floor nests, while cylindrical ones are called nanotubes. Carbon-based materials or carbon-based nanotechnology, it uses carbon atoms to create really tiny structures. And carbon kasi, it is special because it can form different shapes and unique properties. Unique properties like it is super strong and good conductor of electricity. And it is also useful in electronics and in medicine. The second is metal-based materials. Includes quantum dots, nanogolds, nanosilvers, and metal oxides such as titanium dioxides. Quantum dots are composed of semiconductors crystals with hundreds of atoms that can be manipulated to change optical properties. These materials are all made of metals like gold, silver, iron, and other metals. All of this metal-based nanotechnology offers a way to harness the special properties of metals at the nanoscale for some various application in the field of science. Next, dendrimers. These are nano-sized polymers built from branches units. The numerous chain ends of dendrimers may be manipulated to perform biochemical actions such as improving drugs and drug delivery. Dendrimers naman, ito yung special molecules that have a tree-like structure. They start with a central core and branches or arms that have a symmetric pattern. Much like the branches of a tree, parang mga branches ng puno or spokes of a wheel, parang bagay yung mga pattern of the wheel. The example, it can be used or useful in various applications like drug delivery, imaging, catalyst, sensors, or coatings in the films. Etong dendrimers na to, it is a tiny customized platforms that carry things like all of these drug, imaging, catalyst, sensors, and coatings. And lastly, nanocomposites are materials made up of nanoparticles put together molecule by molecule. These are added to products to enhance mechanical, thermal, and flame retardant properties. They also have applications in energy storage and conversion. Ang nanocomposites naman examples include mixing tiny particles with plastics to make them stronger or adding them to metals to make them lighter and stronger. Ito para mas maging something new and improve yung materials or yung devices para mas, sabi nga dito, to have a application in energy storage or be in good conductors of electricity. These are the application of nanotechnology. Medical field nanotechnology is used in drug delivery techniques, particularly using dendrimers. According to a study by David Rudd and Jade Boyd in 2017, gold nanoshell are capable of delivering toxic doses of two drugs, lapatinib and doxycycline, inside breast cancer cells. Utilizing nanoshells in the treatment of cancers could also result in less side effects. In first aid, a bandage that is waterproof, elastic, and able to dissolve in a skin over time was developed by MIT team led by Karp and Blatcher. Imagine, madaming application of nanotechnology at isa na doon yung medicine. Sabi ko nga, examples ko is yung dun sa mga chemotherapy, like yung mga sa cancers din. Ang example dito is sa breast cancer and then sa first aid bandage. Additionally, the unique properties and structures of CNTs provide wide-ranging applications. CNTs have distinct properties, size, structural integrity, and high electronic conductivity that make them ideal electron emitters. CNT-based membranes are used for water desalination and nanoscale sensors to identify water contaminants. This is a graph example of nanoscale titanium dioxide's photocatalysis. This nanoscale titanium dioxide photocatalysis means using really tiny particles of titanium dioxide to speed up chemical reactions using light. It's like a tiny helper that uses sunlight to break down dirt or pollutants, making things cleaner. And these are the various applications of photocatalysis of tin dioxide. Self-cleaning is achieved by coating semiconductors photocatalysis tin dioxide on glass, ceramics, or plastics, according to Benedict's et al. 2000. Tin dioxide also has antibacterial properties when exposed to UV light. Bacteria that cause foodborne disease can also be killed by the photocatalytic reaction of tin dioxide. The nanoparticles of titanium dioxide are also capable of eliminating harmful air pollutants. Scientists from Lawrence Berkeley National Laboratory found that a high-quality tin dioxide catalyst has the ability to remove oxide or N2O about 200 meter per day and typically volatile organic compounds or VOCs 60 meter per day. And lastly, nanofilms can be used in thin films to make them water repellent, air reflective, ultraviolet, infrared resistant, and scratch resistant, like production of eyeglasses, computer monitors, camera to protect their surfaces. Etong nanofilms, ito yung thin layers coating na makikita natin dito sa glasses, computer, and camera that makes all of them waterproof, reflective, and resistant na napoprotektahan tayo sa UV rays. It also help to protect and improve the quality of all of these items.
It includes our discussion. I apologize for not being able to fully discuss our topic because I am not feeling well right now and my voice are not in good condition. But I hope you learned something in our discussion. If you have questions, clarifications, feel free to ask me. Thank you for listening. Good day.